All right. Hey guys, welcome back to the channel. Or if you're new, then welcome to the channel. In today's live session, we'll be covering this topic that is on the screen: monitoring Docker nodes using Prometheus and Grafana. Now, before we get started with all of this, I just want to make sure that you guys can see my screen and that you can hear me properly. So please go ahead and give me a confirmation in the chat. So I know that you guys are watching. I'll take a confirmation again, in the middle to see if you guys aren't sleeping too hard. Okay, so till you guys give me the confirmation, I want to show you guys something. So at here at Great Learning, we have come with the initiative. It's called Great Learning Academy. So you guys should definitely go and check this out. On Google, type in Great Learning Academy, and the first link you get, click on it. All right, so right now, what you need to do is you need to click on this link, and you're going to get a lot of different courses that you can apply for. You have Python for machine learning, introduction to digital marketing, you have premium courses, you have introduction to R, you have financial risk analytics, you have so many different courses that you guys can choose, and these courses are completely free. So we have come up with this initiative of Academy for the whole pandemic situation that is going on, and we want to give out courses to people for free, so they can upskill themselves and make a better career for themselves. So please definitely go ahead and check this out. That is a Great Learning Academy, and try out one of our courses. You have to, if you want to upskill your career, then definitely go and check these out. All right. So now that we're done with that, now I'm going to go ahead and see if there are any people in the chat. And yes, we have Ravi. Welcome back, Ravi. Good to see you that you're here for this session again. Okay, so you can hear. So let's go ahead and get started with monitoring Docker nodes using Prometheus and Grafana. So these are the different things we'll be going through, like what is containerization, what is Docker environment and architecture, what is continuous monitoring, what is Prometheus architecture, what is Grafana, and then we'll be having the practical session. So guys, what I'm trying to do in this session is basically, we will be launching our Docker services, and then we'll try to monitor them using tools such as Grafana and Prometheus. So to understand all of this, I've put up a lot of different topics, especially for someone who's new. I'm going to cover these topics in brief, like containerization, Docker's environment, and continuous monitoring. So if you guys want to check out something more brief about Docker, if you're new to it, I definitely recommend you guys check out the other videos we have on Docker. Like, I go into way more detail than I would over here. It's called Introduction to Docker. So go ahead and check that out on our channel. So Introduction to Docker, Great Learning. All right, with that said, I am going to start the session. So in this session, we are first going to learn about containerization. What is containerization? So let's make it clear that whatever we're going to be doing is related to software development process. So in software development these days, right, you have a standard delivery pipeline, like developer writes the code and the code is taken with its dependencies, it's built into an executable, and is given to the tester, where the tester tests it for multiple different types of tests. He tests it for acceptance testing, integration testing, unit testing, and all the different kinds of testing there are. So the tester tries to make sure that the code is up to mark, or it's of the right quality. If he thinks it's not, then he repeats the cycle. The whole cycle repeats, where the developer tries to writes the code again or rectifies any mistake that the tester has notified him of, and the cycle repeats and the tester gets the code again. And this time what the tester does is, if he thinks it's right, he sends it ahead for deployment. So it goes for deployment. Now this is a standard delivery pipeline. How do we use containerization over here? So normally what happens is, not normally, but there are chances that the code that the developer has written may have compatibility issues while running on the tester system. Now this is the case because sometimes the developer and tester won't have the same environment. Maybe they're using slightly different versions of specific tools. So let's say that the developer is using a certain version of PHP and the tester is using another version of PHP. So they might have conflicts, or they're using different version of the OpenJDK. Developers using 8, testers using 11, then you might have compatibility issues over there. So it's important to maintain standardization, but it's not always feasible to just tell them to add more things to their system, because you can't keep on adding more things to your system. There's a certain limit, because you'll be doing a lot of projects, and for each project you can't keep on adding new environment. Like, you can, but it's a lot of effort. So instead of doing that, we have come up with better method to do this. we use containers in this process where we take everything that is required to execute this code. That is, the code itself, the dependencies, the environment which is used to run the code, like it can be operating system and it can be the tools that are used to compile the project. So all of it's taken and put into one single container. You can think of this container as like a box in which you keep a lot of items, and you do everything inside of that box itself. So instead of basically sending the code directly, what the developer might do is he might send the container with all of the things that are required through the pipeline. So it will go through the pipeline where it will get built, then it will go to the tester, where tester will run his test scripts, and then it will go to a staging environment where it will wait as a release candidate. And if the team lead or whoever is leading it approves it, then it goes for the production environment where basically it's available to the end users. Now you might be thinking, does the container stay everywhere? Well, it actually depends on your requirements. Sometimes you might need to use this container, sometimes you won't. But when you're going for talking about deployment these days, almost all types of deployments are done on containers themselves, because containers are very easy to manage, and they give you a lot of flexibility when you want to scale. So that's what containerization does, and it helps us to basically do every small process in software development. That is, it helps us to develop the code, it helps us to build the code, it helps us to test the code, and it helps us to deploy the code also. So that's what a container is. It is like a software that wraps up all the parts of a code and all of its dependencies into a single deployable unit that can be used on different systems and servers. You have your code, which is taken with the libraries, which is taken with the environment, which is taken with all the frameworks, with all the different tools, and put into one container. So that's your container. Alright, so why do we need containers? Again, two reasons: to maintain consistency across your different environments in your software development process, and for microservices. So in microservices, you basically take your software and divide it into multiple parts. So you have, like, so let's say you have one software which has 5 features. So all those 5 features together will make the software. To deploy this particular software, what you do is you take all those 5 features and put them in their individual containers, and then you connect these containers using some kind of network, and then you deploy this set of containers on a cluster or on some location. Maybe you're using cloud, so you do it using cloud, so you deploy it like that. So it helps us in these two things, where you keep consistent environments and where you can deploy your software using a microservices architecture. All right, so for all of those who already know this, you guys can join in a little bit later, or keep on watching. I might add new stuff for and again, a reminder, guys, if you want to know all of this in detail, we have a video for this already. You can go ahead and check that out. And feel free to ask questions in the chat. I will periodically look at the chat and see if there are any good questions that you guys are asking. I'll try to answer them, because that's the whole point of this session, to help you guys learn. Alright, so now let's talk about Docker. We know what containerization is. What is the need of Docker? So Docker basically helps us to develop, build, deploy, and execute software in isolation. So we talked about containers, right? So Docker basically helps us create those containers. You can take any software and put them into a set of containers, and then you can go ahead and deploy them in those set of containers. And it also helps you give a layer of security, because security is again important in software development. You want to make sure that the assets you have created is not stolen by someone else and used for their own purpose. You put a lot of time and money and effort into it, so you need to keep it safe. So let's look at the Docker environment. So again, a revision of what is there in the Docker environment. You have the Docker engine, you have the Docker objects, Docker registry, Docker compose, and Docker swarm. So Docker engine is basically the engine. It's the engine of the whole process, the whole tool, where it does everything. It basically creates all the objects, it manages all the processes. Any request that you give to the engine, it will process it and give you a valid output. And it consists of 3 parts. That is a Docker CLI, that is a command line interface. Then your Docker objects. Then you have Docker API, which is the Docker application program interface, which basically communicates all your requests to the engine. And the last part is the daemon, which actually does all the processing. Then we have Docker objects, like your images, your networks, your volumes, and all your storage devices. Those come in Docker objects. And you have Docker registry, where you basically store images. So then we have Docker Compose and we have Docker Swarm. So Docker Compose is basically a service within Docker that allows us to create multiple containers at the same time. Now, Normally when you create Docker containers, you use single command called docker run command. But what if you want to launch a very comprehensive service, add everything in the starting itself, so you don't have to keep on writing it, one by one in line. So that's where you use Docker Compose, where you create a .yaml file in which you put in all of your configurations, and then you deploy it using the Docker Compose up command. Now you can do this on a swarm also. So what is a swarm? Swarm is basically a cluster in which you have multiple Docker hosts. So if on one system you downloaded Docker and on the second system you downloaded Docker and you want to connect both of these nodes together, then you connect them using a Docker swarm. You don't connect them, you just put them in a Docker swarm where one is a manager and the other is the worker. And these nodes can have their individual containers also. So basically Docker Swarm is an orchestration service that allows us to manage multiple containers at the same time. So that's your Docker in brief. Well, let me just show you guys your Docker Compose creating multiple containers, and your Docker Swarm, which helps you manage multiple containers, in which in a swarm you have generally one manager and multiple worker nodes. Manager is the one who distributes the tasks to the worker nodes. This is to basically reduce the load on the singular nodes. All right, so let's look at the Docker architecture also. Wait, we have a question over here. All right, so Ravi's asked, are we going to see how to integrate Docker with Prometheus and Grafana to ship Docker logs and analyze it? Are we going to do the integration using Jenkins plugins? Well, I will be doing it on a local system. But since you asked about Jenkins, we'll think about a project that we can do later where we integrate the whole thing, where we use Prometheus and Grafana attach, and we attach it and we monitor all the logs coming in from Jenkins, the Nginx server we are using, any application that we are Dockerizing, or all of that. But in today's session, what we will be doing is basically we'll be launching a Docker Swarm in which we will be launching, within itself, we'll be launching Grafana, Prometheus, and some other services that I'll tell you guys about, like CA Advisor and Node Exporter, which basically, create endpoints for Docker services and Docker Swarm so that we can collect the data from there. So that's what we're going to be doing. So, okay, all right. So we have the Docker architecture where you have the CLI, you have the host, and you have the Docker registry. So in Docker CLI, you have the different commands like Docker build command, Docker pull command, Docker run command. So your build command will basically tell daemon to build an image for you. So you have to write a Docker file and you will build the Docker file into an image. It can be an Ubuntu image. Then you use the pull command. So pull basically tells Docker daemon that I want a certain image from the Docker hub or any Docker registry. So daemon will search for that particular image on a Docker registry, and once it finds it, it will go ahead and replicate into the local system. And then we can run Docker run command. So run will basically ask daemon to run a specific image that you have specified. So this is for creating containers. So if you have Ubuntu image and you want to create a container out of it, you can just type in Docker run, specific flags and then the name of the image, and it will go ahead and run the container for you. So this is your basic Docker architecture. All right, so Neeraj has asked how container networking works, concept of overlays and mount points. So in Docker, you have multiple containers. So you have a lot of containers that you might run in Docker. So if you want to connect them, you use specific network drivers. You have a lot of different types of network drivers. You have bridge network, which is the default network. Then you have the overlay network. Then you have other special networks like MAC-VLAN network, or you have host network. Or if you want to disable the networking for a container, then you can go ahead use the none network. So you have a lot of different types of networking. So the two main ones you guys should be concentrating on is basically the bridge network and the overlay network. So what bridge network does is it basically connects two containers or a set of containers together if you want, and it creates a layer of isolation within those containers. That means that if you connect three containers together using a bridge network, no other container can communicate to this set of containers unless they have the same bridge network. The overlay network is generally used for different nodes where you have multiple Docker nodes, like systems within which you run containers, and you want to connect them together. That's when you use overlay networks, and all services within overlay network can communicate with each other. All right. So we have another question. If Hassan, please conduct a session on monitoring using Nagios and shell scripting detailed tutorial. Okay, yeah, I'll keep that in consideration about Nagios and shell scripting. How Docker image gets created layer by layer. Okay, so yeah, so like Ravi said, Docker is created layer by layer. So images, basically inside of an image, right? You create an image by writing set of instructions, and those instructions, when they layers, when they are forming the container. So let's say you written four instructions, so you'll have those four layers of instructions over the Docker container. So to go into this detail would take a little bit longer. So I hope that was adequate of an explanation, because now I want to move on and explain to you guys about monitoring. So why continuous monitoring? So in DevOps or even normal software development, you need to monitor your application always, because you need good feedback, so that you can improve in your later cycles. Obviously, you've deployed a good software once, but there's always room for improvement. So how do you do that improvement? Or how do you keep on monitoring the health of the particular system? How do you maintain it? So that's where monitoring comes in. So continuous monitoring is an important part of software development. It is something we take up as a measure to maintain the health of a software and to improve the quality of the software. This is based on the feedback we get from the insights gained from monitoring. So you have a lot of companies like Spotify, Windows, Adobe, Amazon, Netflix, Google, Bose, Slack, IBM, Adidas. All of these companies do monitoring, and these are just a few to list. Almost every company does monitoring. You can be a very big company, a large multinational corporation, or it can be a mega corp like Google or Apple. It can even be a small startup that's just making a product for their own locality. Everyone that tries to do monitoring because they want to make sure that the product they're providing or the service they're providing is healthy and it's always up. And if there are any issues that are being caused, they can figure those issues out by monitoring it. And if you want to make improvements after you learn from those improvement those monitoring insights that you've gained, you just do the improvement in the next cycle. You try to do it. All right, so basically what happens is you can collect multiple types of logs, data like logs, and server performance details, server metrics, system metrics, your software's metrics, and your networking metrics, how well it is doing, how many hits are you getting, is it is the API working or not. All those kind of details are collected. Then you create meaningful visualizations for these particular metrics and logs that you have stored. And this basically helps you to create an excellent product. It helps you to increase your revenue. It basically helps you to scale your operation. So scaling operation is important because you always go with the mindset that you're gonna improve your business. So you need to keep that buffer zone in your mind that you will be improving that much. So you should be able to scale your services or increase the number of servers or products or services you're providing to that level. So you should try to design a system beforehand, thinking about the future where you can scale easily. To do this kind of thinking beforehand itself, you need to monitor your systems and see where the vulnerabilities are and how you can patch up those vulnerabilities, and study your architecture itself. So that is again with monitoring. All right, so we have different types of monitoring like system performance, process monitoring, integration, application performance, business monitoring, where you check out the business activity also. Like companies like Amazon and Google, they collect a lot of different types of data. Like even if you're watching this on your phone, or if you're watching this on on any kind of device, there is a high chance that your voice is being recorded for maybe with your permission or without your permission. They're recording it so that they can understand what you're talking about daily, and they want to sell you those specific products that you're talking about. So they try to do targeted ads by monitoring your habits, what you do daily, all those kind of things. So again, there's business monitoring. Application performance is basically checking how well your application is doing. Like, is it up or not? If it's up, then how much resources is it using? Is it using more than the threshold that we have assigned? And if it's using more than the threshold we have assigned, why is it doing so? Is there a particular algorithm that we have put in? It's not as optimized as we thought, and we need maybe, so with that insight we know that next time we will try to optimize that algorithm. Then integration, like how well it is being integrated to other services. So is it like barely patched up? If something, if it talks to the other service and it sends a signal that the other service cannot accept, will it break the whole process monitoring, like processes that are running within the system itself, maybe to enhance the application, or maybe to for other purposes. You need to monitor that also. And system performance, basically checking how well your system is doing. So these are different types of monitoring. So you have a lot of tools. You have ELK stack or Elastic stack. Then you have Prometheus, Grafana, NagiOS, Splunk, and then Amazon CloudWatch. So you have a lot of different types of tools. A lot of them are paid. Like Splunk is a very expensive paid tool, but a lot of multinational corporations use it. Then you have Amazon CloudWatch, which is an Amazon service, or you can use open source tools like NagiOS, Prometheus, or Grafana, and even Elastic Stack. So Elastic Stack is a set of different tools that Elastic has made, like Elasticsearch, which is a database, Logstash, which is a collection agent slash processing thing, and then you have Kibana, which is basically like Grafana, where it creates beautiful visualizations that are good to look at, and help you get better idea about what you're doing. So you have a lot of different types of monitoring tools. So the one we'll be concentrating on Prometheus and Grafana. All right, so let's see what Prometheus and Grafana are. So Prometheus is an open source tool that is primarily used for metrics monitoring and alerting. It was developed in like 2012 to fulfill SoundCloud's need of having multi-dimensional data modeling, scaling, and simplicity in their monitoring capabilities. So they came up with it because they thought the current tool that they were using, or whatever method they were using, wasn't good enough for their needs. So what they did is they came up with Prometheus. It makes use of something called PromQL, that is your Prometheus's query language. It's a very powerful querying language. You can use it to monitor and query a lot of different types of data. And Prometheus is a pull-based metric monitoring system, which needs the location of specific endpoints. So you have to expose endpoints on your services or whatever you're monitoring, and then Prometheus will basically go ahead and scrape those endpoints. So that's what Prometheus does. So if you guys want the distinction between Prometheus and Grafana, so Prometheus is the one that does the heavy lifting of collecting data. So it will look at the endpoints. It will first do a service discovery. Actually, let me show you the architecture. Okay, first we'll check out the Prometheus features, then we'll look at the architecture, so you guys will get better understanding of what it is. So it has a multi-dimensional data model. It uses PromQL, service discovery, where you can discover the services that you want to monitor, then time series collection via pull model, and no reliance on distributed storage. All right, so let's look at the architecture. So we have Prometheus. Now first it uses the service discovery to look at the service it wants to collect data from, and then it pulls metrics from those scrape targets or whatever service it is. You can do it directly, and you can even use exporters. There are specific exporters that expose endpoints. Like with Docker, we'll be using node exporter, and it will feed those metrics to Prometheus, and then Prometheus will store them in a local storage. And once it's stored it in the local storage, it's going to go ahead and use the PromQL to create visualization in your Grafana. So that's the difference over here, where Prometheus is basically looking for the targets. It's basically taking the data from the targets, but it's not the one doing the visualizations. It's just storing everything, all the metrics. Now Grafana is where all the visualizations come in, where Grafana is solely dedicated for just being the data source place, like for being the visualization tool, where you can create very beautiful dashboards, and in dark mode, because dark mode is the best. So you can create very good looking visualizations, charts, and you can put them in Grafana dashboards, and you can share them with anyone you want. And it's very easy to add dashboards also. If you don't know how to create one yourself, you can just get someone else's dashboard. Someone else has put in a lot of time. You just take that dashboard and use that dashboard. So this is basically a Prometheus and Grafana. Let me reiterate. So Prometheus basically does a service discovery. Once it identifies the service, it goes ahead and pulls the metric from the endpoints that may be exposed from the scrape target. and if it's not exposed, then it uses an exporter to do so, and it stores all of that data in local storage. And once it's been stored in the local storage, we make use of the PromQL to find the specific data that we want to monitor. So if we want to monitor how well Prometheus itself is doing, we will type in the specific query for that. And we will use PromQL even in Grafana. So you can create the same visualizations based on the same data. So Prometheus is the data source for Grafana. So I hope you guys understood that. All right, so there's a question over here. All right, so in case of microservices implementation using containers, how communication among them works. So you normally use an orchestration tool to deploy your services. Your services are basically your containers with their own replicas. So when you deploy them, right, the infrastructure, the place where you deploy them, suppose you deploy them in a Docker swarm. So in a Docker swarm, there is a already default network called ingress. So it's an overlay network. So it like forms a layer of networking across all of the containers, and it connects them, and it allows us to basically so all these containers within the network, they have their names exposed to the other containers. So if you are within the same network, these containers, if they are within the same network, or these services, if they are in the same network, and if they can look at each other, then they know each other's names. So that's how they interact with each other. They interact with each other using the names of their services. And then in the end, you expose the swarm to the public, right? So that's how it would work. So that's for Docker Swarm. Even in Kubernetes, you follow a similar kind of plan, but it kind of can depend from orchestration to orchestration to. If you're using some cloud service, it might be a little different. Oh yeah, and Prometheus also has one thing, that is pushing alerts. So you can set alerts in Prometheus for specific things. So if some resource usage is maybe way too high, then you can go ahead and send a alert using an alert manager. So you have these different parts for Prometheus. Alright, so what is Grafana? So like I talked just now, discussed a lot about Grafana. Grafana is an open source monitoring solution that allows us to using collection agents like Prometheus, using beautiful visualizations that give us in-depth insights. Now let's look at Grafana features. So a lot of features over here, like it can help us visualize the metrics. It can help us, create dynamic dashboards which are, taking data in real time and display the data in real time. Then you explore metrics and logs. So instead of using Prometheus, you use something else. If you're using Loki with Grafana, where Loki is a logging tool, then you can store the logs in Loki, and then visualize them using Grafana. Then again, it has alerting feature, and you can use mixed data sources. So the good thing about Grafana is that you can use it with almost any type of data source. Not almost any, but the available types, the one it supports. But the amount it supports is like very high. Other compared to other tools like Splunk or ELK, there they don't have this kind of supportability. Splunk can only talk to its own components within itself, and then Kibana is generally used only with Elasticsearch and Logstash. All right, so now let's move ahead and learn how to monitor using Prometheus and Grafana. Hello. Yeah, so let's go ahead and yeah, so I have already basically created basically the swarm. So I'm going to go ahead and name this Docker manager, Docker worker, Docker worker. Let me go ahead and launch this. Let me go ahead and install Docker on this. Sudo apt install docker.io. And open up the workers while the manager is loading up. While I'm doing this, guys, feel free to ask any questions in the chat. Paint my workers a different font color. Let me go ahead and do this. Applied. Now we're gonna do this with worker 1 and worker 2. Let me name them also. Oh, give this a more red color, or you can give it yellow. Keep it green. Looks cool. Alright, so let me go ahead and install Docker on this also. Install app install. Alright, so what we're gonna do first here is let me get some access. Now I'm gonna go ahead and create a swarm. So swarm init. Alright, so I've created my swarm over here. So I'll take my worker join token. I'm gonna go ahead and paste this over here. Yeah, we have to do it using root access. Right, so we have made this join. So let's docker install on this. Alright. So you guys can do it with me also if you want. I already have the docker compose file prepared. So I'll just explain to you guys how it works out. Well, it's not exactly mine. It is Stefan Prudence. We're going to be, using it. So I'll explain to you guys how this works out. Okay. All right. Any questions, guys? Feel free to ask. All right. So now I'm gonna paste in the command. All right. Now to make sure it's there, docker node ls. All right. So we have our swarm ready. So this is our swarm. Now we're gonna go ahead and clone this repository. So you guys can go ahead and check it out. remicode/swarm prom. Go ahead and copy it, and we will clone it in our system, our master, node. So git clone. Let me create a folder. All right. So we're gonna go ahead and clone this. Right. So let me go inside swarm prom. All right, so let you guys all the things over here. So what we need to check out is, there is an alert manager, there's caddy, there's docker compose.yaml, there's docker d exporter, grafana, node exporter, and Prometheus. So let me open up docker compose.yaml file. Alright, so guys, this file, right? So this is an important file over here. So you guys can see we have we have one network, that is net. It's an overlay network and it is attachable. Then we have volumes for Prometheus, for Grafana, and for Alert Manager. Since we'll be launching Prometheus and Grafana as containers, so if they go down, we want the data within them to be stored. So we'll be creating volumes for that. And then we have specific config files using which we want to create launch specific services. So we have these config files over here. And then we have the services. So we're going to be launching Docker D exporter. One second, guys. Let me go ahead and all right, so we have basically first Docker D exporter. So Docker D exporter is basically for collecting the Docker daemon metrics. But the thing for this is we won't actually be using this. We won't be collecting the daemon data. What we will do is we'll basically collect the node data. So let me tell you what a node here is. Basically, our manager is one node. Our two workers are the other two nodes. So we'll be collecting the node data, and for that we'll be using the node exporter. Now Docker D exporter, to make it work, we have to enable an extra metrics ADDR. Right now we're not going to do that. So when you guys see all the targets up, you'll see that Docker D exporter is done. All right, so then we have CA advisor. So basically CA advisor is basically for using for exposing the container metrics. So when we want to expose the container metrics, right, so we'll be using CA advisor. That's its job. So you can see it's using the Google CA advisor image over here, and it's going to be working, it's going to be within the network in which all the things are connected. And you can see the volumes that he's using. If you go down, so you can see that it's going to be deployed globally. When I say globally, right, so when we build this docker compose.yaml file, it's going to be in every node. Like we want this to be in every location where from where we want to collect data. So if we have 3 nodes and we have containers on all 3 of those nodes, and if you want to collect data for all 3 of those nodes, then CA advisor should be on all of those 3 nodes. Okay, so there are some resource limits also being put over here. For memory limit is 128. All right, then we have the Grafana. So Grafana is also something to be launching as a server, and you can see that it's using this particular Grafana image. The network is again it's connected to net, and there are some environment variables that already been set over here, just like the admin username is going to be admin, and the password is also going to be admin over here. So it's easy for us to set it up. Then it's going to be using that volume, and it's going to be deploy mode is going to be replicated. So this means that it will not be everywhere, it will be there where the resources are adequate, and it will be replicated over there. Only one replica over here. And there's a placement constraint over here that it will only be on the manager, right? So where node role is equal to manager, and that's where it's going to be placed. So it's only going to be on our main thing. Then we have the alert manager, which is again for you you basically alerting people. One sec, guys. All right, so yeah, we have the alert manager. We have some environment variables like Slack URL and Slack channel and the Slack user. And you guys can see similar things configured over here, like it's going to be replicated, and this placement is manager, where the role is manager. Then which is basically the dashboard for the alert manager. Then we have node exporter. Now node exporter is something that we will be using a lot, and node exporter basically is exporting the node metrics. So that's what its job is going to be. So it's going to be globally. So that means, it's going to be deployed on every node. So we want to collect all the nodes data. And then we have Prometheus again. Now Prometheus is also part of the same network. And in Prometheus, you guys can see the configuration files it's using, and it's going to be basically deployed as a replicated. Then we have caddy. Now caddy is basically the authorization thing for Prometheus alert manager. So it's not going to be basically helping us collect data, but it will be creating a level of security over these services. So if you want to access Prometheus or Unsee or Alert Manager, then you have to set your password and this thing. Feel free to go ahead and clone this repository and try this out, play with it. Alright, so let me go ahead and exit out of here because I want to show you guys the prometheus.yaml file also. So scrape targets are going to be. Alright, reconnected. Okay, guys, we are back. So this is the syntax, basically Docker stack deploy, the name of your basically the name of your .yaml file and the name of your stack, what your stack name is going to be. Let me press enter. So it's going to start services. So you can see there's a lot of things. It's first creating the network, is this network, and then fig files, and then the services, Unsee, node exporter, Prometheus, caddy, a Docker exporter. So the three important services that we want to know about is C advisor, Docker exporter, C advisor, and node exporter and Prometheus. So basically, deployed on our swarm. Now to check that, you can do a simple method by typing docker ps. It will show you all the containers on the node you have on. Okay, on this node you guys can see a lot of data and you guys can probably can't figure out anything. Let me go ahead and reduce the size of the font. Maybe you will be able to see the correct formatting and everything. All right, let me go ahead and do docker ps again. Okay, now you guys can see all the different services. So we have basically Grafana up on our main node. We have alert manager, we have Prometheus, and you guys can see at what ports they are exposed also. So basically we have all the services running. Now you can do one more thing. I will type in docker ps over in one of our workers, and you guys can see sudo docker ps. If I do sudo docker ps over here, you guys can see a specific set of services running over here. So according to our logic, CA advisor should be running over here, and node exporter and caddy, because they're all global, the modes. So you can see that CA advisor over here, caddy is over here, and swarm prom is also over here. And we can see the same thing over here also. Docker ps should see the same thing, and we can see the same thing. So we have successfully deployed our thing. Now let me show you how you guys can access it. So we have launched it on a manager, so that's the swarm IP. So you need to access it basically from that. So in my browser I'm going to put my IP, and we're going to put 9090 because that's how you access Prometheus. So Prometheus is basically exposed at the host's port 9090. So the username is going to be admin, password is going to be admin. If I sign in, so it's taking me directly to this particular area, graph. Let me close everything else. While this is opening, we can go ahead and launch Grafana. Now Grafana opens at 3000 port. So our Grafana loaded faster. Right, so Grafana is loading. You can go ahead and enter the same username and password, admin, because it's being configured that way. Alright, so it's taking a lot of time. We can go ahead and check out 1900. Alright guys, you know what, go ahead and ask your questions while this is all loading. Well, so there's a question what exactly it means when you say swarm is ready. So I didn't mean anything specific. There is no technical jargon for this. I just meant to say that I have created my swarm, and we have all of our services running on it. So guys, this is Prometheus. So you can see the basic Prometheus layout is very basic because its main job is to basically collect data, so it's not fancy at all. Now if you click on status, you need to go to targets. So that's where we will see all our endpoints and we'll see if they're up or not. So if they're not up, then Prometheus will not be able to basically, collect data from them. If they are up, that means we can collect data from them. So right now, except dockerd exporter, where we did not change in Docker daemon itself, so that will hide it. And then we have CA advisor, again container metric exposer, and it's working perfectly fine. And it's working on all three of our nodes. And you can see that this is the private IP, or the one it is using in the network net. And we have node exporter, this is for collecting node data, and we have Prometheus's own metrics also. You guys, I'll show you something cool. Okay, so let me go ahead and get the metrics. All right, so okay, so it's very slow. Let me go ahead and oh, we need to wait for Grafana to load because Prometheus directly. I'll show you guys how you can create graphs in your Prometheus itself. So if you want, you can go ahead and choose a particular okay, this is a little bit too slow. I want to show you guys the raw metrics because the internet is very slow. Okay, thank God. So with the Prometheus metrics, you can check them out. Just take. You want to see metric handler request? Yeah, that sounds cool. So because it has a lot of requests, let me go ahead and execute this. So you guys can see on the console all the different logs you have of it, the metric of it, requests of it, and you can go ahead and create a graph. Okay, so my last just effort didn't work, so we'll don't worry about this, guys. We'll do a repeat session where I'll show how it works. In meanwhile, you guys can go ahead and get this clone this repository onto your own systems and just perform the same exact steps. Your IP address and port 3000, that's where you get Grafana, and Prometheus you get at 1990. So